Go ahead and stop share. Do we want to stop the recording now, or?
Probably.
Well, if we're gonna have a little bit of chat, what I like to do is cut the main segment and then keep the chatter. So if somebody wanted to just hear our shop talk, they could hear that.
Oh, okay. I'll leave the recording on for now.
Boom! Presentation done. Clap, clap, clap.
Ooh, sorry, full 2 hours. Didn't mean for it to be quite that long.
So my question,
Okay.
this game 3 years ago, and now you've had more experience of Rust. If you had to do it all over again, what major differences would you have made?
Well, I actually made most of the major differences already. I spent like 4 hours yesterday night, like refactoring my Rust 2015 style code more. I pulled out the entire, I used to have an audio thread that did the audio handling, and I actually combined that with another project I had developed, an even nicer audio engine. I pulled that out into a separate audio engine and then made this use that instead. So that was one big refactoring. And then I just a whole bunch of stuff that wasn't very idiomatic. Like if I had to return something semicolon at the end of a function, I changed it to just be the tail expression without the return and the semicolon. I improved a lot of loops. I added the world. In my Rust 2015 edition, there was no world. Like I passed everything separately. Also in the 2015 edition, they were actually concurrently running threads, but I wrapped every single thing individually in an arc protected mutex, and then locked every single one of them at the top of the render thread, and then unlocked them at the bottom of the render thread. So it's sort of similar. Like we would lock everything in the render thread, which would block everything over in the main thread, and then unlock, and then it would lock back and forth. And it was just so much boilerplate for lock this, lock that, lock this, lock that, unlock this, unlock that. And it was just like, you know what? Just sending it, wrapping it up in a world and sending it back and forth across a thread is equally inane, but there's a lot less boilerplate and a couple less concepts too, because it was a lot to go over channels. And I also used a channel to have like a stop sentinel. I would send over a channel a stop, and then things would check to see if they received anything on the stop channel, and it was just like too complicated. So I just simplified all of that to just sending the world back and forth and seeing if the channel gets closed. So that's like way better than it was before. Let's see what else. There's a bunch of stuff. Before I was using strings all over the place. So like everywhere that I had literals, I was doing a toString, and then I was storing them in strings. And so there was like a lot of back and forth between strings and string slices. And I stripped all that out and just used string slices everywhere, so I don't have any conversions. I used to have like 3 or 4 different integer types, and I was casting between them to get to the different places, because like you need a U16 for the cross term, but you needed, I needed a U32 in this other place, and like a U size for the indexing. So I was casting back and forth a lot, and I simplified that to U size everywhere. What else? It's quite a bit cleaner than my initial version 3 years ago.
Yeah, it sounds kind of like the standard way that a Rust project progresses. You start out with, just all of the standard easy way to do it real quick, and then you realize that there's another way to do it a little bit cleaner, and it just
tell you what, doing the refactoring in
time.
Rust, like I've done this kind of refactor in Python projects before, and it's terrifying because it's change something, run it, where does it crash? Okay, once it crashes, you're like, okay, I know where to go fix. But it's like, have I found the places? Or like, does it actually accidentally handle it sort of differently? Where in Rust, it was like, oh, change a type. Boom, you've got these 8 errors you need to fix in your program now. It's like, this is the wrong type in these 8 places. And it's like, it's super nice to refactor Rust code.
Are you
I've found that too.
GitHub anywhere?
What's that?
Are you using Rust at all in your day job, or trying to?
Oh, I wish. I am not using it right now. I am I am working on making Rust a paved path at GitHub, which means I'm doing the bureaucracy paperwork of advocacy to say that like this is an appropriate language to use in certain circumstances. And like once I get through those hurdles, which is probably going to be like a year, 18 months, 2 years or something, then maybe people at GitHub can use Rust again.
Where would you hope to use it?
My team that I manage at GitHub is the actual Git storage team. So we manage all of the, several 100 million Git repositories. And so we do a lot of actual interaction with low-level performance sensitive stuff that's dealing with actual Git repositories. They turn out to be amazingly complicated. In some ways, they're super simple conceptually, but in actuality and algorithmically, they are super complicated to make work fast.
So do you use like libgit or?
So libgit2 was created by a member of my team.
Oh.
And we use it in specific places for a few specific purposes, but we actually use Git itself under the hood mostly in most of the places.
So are you using C right now or C++, or what are you using?
libgit2 and Git are both written in C. So I've got C programmers on my team, and they contribute upstream to Git and libgit2 in C. And then at GitHub, we are also a big Ruby on Rails for the whole front end. So like Ruby permeates things, so we run into that all the time. But our main network services are in Go, which is nice because our network services used to be written in Ruby and C, and we've been porting them from Ruby to Go and C to Go. So
definitely a step up.
Yeah, the Ruby services were we had to scale them, like run thousands of instances to get the performance. And then like, the problems with C, we're a Rust user group.
Yep.
It was fast enough, but yeah. Oh man, just go to C and it's like, re-implement everything in the whole flipping world from scratch.
It is very nice when there's a community that has a leader.
Yeah.
I wish you luck with it. I wish you luck in your 18-month journey on that then.
Thank you. Bureaucracy is not my favorite thing, but hey, it's the life of a manager, I guess.
By the time you get it approved, everybody will be using it.
It's true. Like I've started, there's been like, we've got a Rustation Slack channel for GitHub because we use Slack a lot. And there's 40 something people in it. And it's just a complete like interest group. People have just found the channel and joined it spontaneously.
Nice.
What is GitHub's view on asking permission versus seeking forgiveness?
Oh man, that has radically changed over the years. GitHub until 2016 was proudly we have no managers at this company. And then it went through this transition from 2016 to 2018 of no, like we're too big and this is falling apart. We need managers to like have some kind of structure. And then in 2018, the whole Microsoft acquisition thing got announced. And then 2019, we actually went through with it or something like that. Might be off on my dates.
Yeah, I mean, they're using Rust at Microsoft now, so shouldn't that make it easier?
You think it should, right? But we're...
Microsoft is very much not unified.
Well, not only that, but GitHub is an independent organization, and we're very proud of that. And so just because Microsoft does it is sometimes a reason not to do something.
Just because one group in Microsoft does it is sometimes a reason for other groups to not do it.
Right. So, yeah, but like that is actually part of my evidence for like, look, there are these really nicely well-written blog posts by the mothership that say this is a wonderful language to use. And that actually lends it legitimacy.
What's the main pushback you get? Just the cultural issue or just other concerns?
It's mostly been, we have been growing so freaking fast that like, we got to this point a few years ago where it's like, stop doing different languages. We just have to like no more new languages because we have to do like everything we do on .com. We have to ship in an on-premise appliance for GitHub Enterprise as well. And like trying to crunch down every different language ecosystem into the appliance is like super difficult. And so they just sort of like came up with this, like, don't, stop. Like, no new languages. Rust didn't make it in under the wire.
Isn't just saving the expense of just the RAM that you need on one of those appliances worth an entire developer's year or 2 years, maybe his entire career? I mean,
well, see, that's the problem.
Ruby,
is it takes more than a developer year or two. It takes many.
Yeah.
I'm just thinking about the entire size of the ecosystem you bring with.
Daryl, you froze on my screen.
You lost.
Come back to us, Daryl. Wait, you're moving a little. So if you turn off a video, sometimes that helps if your connection's shaky.
Can you hear me if I turn my camera off?
Yes, now we can.
Better.
Or we could. Are you talking? Blast you, internet. Why can't you be reliable?
So Amazon's apparently doing everything in Rust these days.
Amazon was I worked at Amazon before GitHub. And that was a really interesting environment. They've done a really fantastic job in some ways of balancing between super strict centralized control for some things and extremely flexible, localized control for other things. So for example, they are very centralized about, you will have an API that's accessible over the network, and you will support your service. You will run your own service, and you will support your own service, and you'll expose it over the network. Like, there's no question. There is no sharing. Two teams can't like share a database. You can't like mix your code up. Like, no, you're separate. But like, they've also got the top-down edict that you may choose whatever technologies you want to run. Like, you can choose any language. You can choose any, format. You can use JSON. You can use XML. Like, whatever you want for you. Like that is all the local team gets to choose. And then they also do the like, and here are the ones that we've made easy. They're, we made paved roads, and it really means just like, we've got recipes you can use and tooling you can use and blah, blah, blah. And they also have the very strict top down. If there is an Amazon thing for it, you must use it. You can't use any competitors, anything, which is super annoying when you realize that Amazon competes with everybody.
Yeah.
You can't use anybody. They've got their own internal Jira. They've got their own internal, Git source control. They got their own internal everything, and like none of it is featureful as the external version, and so somewhat annoying as well.
Is it all as ugly as the AWS dashboard is?
Uglier. Quite a bit uglier.
Yeah.
And slower. Oh my gosh. That's one of the things that drove me nuts at AWS is like the internal Jira tool. It's like every click, it was like, okay, now wait 15 seconds minimum for something to happen.
Oh gosh, that's what KSL is like. Have you ever used KSL to search for something like a car or
classifieds? Yeah.
Yeah,
I haven't used it in a long time. I don't remember it being that bad, but
yeah,
oh, it's so bad.
It worked okay for me, but I don't usually search it. I usually just post. Usually it's like, this thing I don't want anymore. It's for free. Come get it.
I was looking for cars. I've over the past decade, I've looked for cars several times, and I've used KSL every single time. Not necessarily that's my final purchase, but it's part of the process. And it's like it must be reading in the entire database of all 600,000 cars without indexes, manually like doing a full table scan, and then returning back results.
Either that or they just stuck it all on S3 and they're iterating through all of the objects.
Yes, yes.
I just did a search on KSL for a Corolla, and it did take like probably 10 seconds.
And
Which,
and then
be a
hit
lot
the
worse.
filter option. Hit the filter option. Yeah, that's when it really starts to get slow. Anyway,
So,
thanks, Nathan. This
Yeah.
was pretty awesome.
Yeah, that was awesome.
thank you.
Yeah. I enjoyed it.
Thank you.
Welcome. And Rust 142 came out today. Looks pretty awesome.
Yeah, I love the line number thing in Panics.
I know.
Yes.
It's like,
Why didn't they do that like years ago?
yeah.
I mean, we could say that about a lot of things, but priorities.
Apparently there was some machinery under the hood that needed to be put in place to make it happen. But I don't know. I'm glad it's there now.
I have to say that some releases I'm like, meh. Like Rust is sort of like where I want it. Nothing that changed like matters to me, which is sort of a nice feeling in like, oh, Rust is getting more mature. And then these come along and like, oh yeah, there are rough edges. Thanks for fixing them.
It is
Yeah,
such
I've got
a
to say that
delightful language.
the matches macro, I've actually wanted that a lot.
Oh yeah?
I mean, I don't know about a lot, several times. So just like, I don't know if you all haven't seen it, but it's just a macro that says basically if you ever have a match expression where you're just trying to turn something into true or false, and if it just matches a pattern you turn true, then now you can just use this macro to do it instead. So super nice.
Yeah, it looks pretty ergonomic. Reminds me of format.
Yep.
The format macro that makes a string?
Mm-hmm.
I could tell you said something, AJ, even though you're muted.
Yeah, I was just clicking on mute and then very surprised that you answered. But because of the context in which we were speaking, I thought you were talking about a language that was called format.
Oh, no, sorry.
It wasn't you that did anything. I just that's the way I thought of it. Well, I've got to get off and attend to have a bio break, get something to drink and all that. So I'm gonna peace out. It's good to see everybody again or hear everybody again, and we'll figure out how to do this again next month. Lightning talks over Zoom.
Yeah.
But I think to this virtual meeting tonight worked fine.
Yeah.
Cool.
I think it went pretty well.
I
Discord
can host
also.
this as long as I'm working at GitHub. I have this commercial Zoom account and I'm happy to host if necessary.
Awesome. Thank
Our
you.
Utah Rust Discord has a screen share mode for the voice chat as well. So if we want to use that, that's a free option that we have on the Discord.
Sure, we could try that.
Oh yeah,
Does it
I meant
record?
to join in on that.
Could be handy to use for code review things and, hey, how do I do this thing? Or why is my code not working?
I fell in love with Discord right as I joined GitHub, and everything GitHub was Slack. So I was like, oh, okay.
Yeah.
But Discord uses actual Markdown. That's what drives me nuts about Slack. It's like it looks almost Markdown, but it's not. And definitely no code syntax highlighting. Slack.
Plus,
I mean, you can do your little
Discord
code
uses
snippets.
Rust.
That's true. I almost never see code snippets used on Slack.
Oh man, I do it all the time.
Do you?
Yeah.
Huh. It's just a GitHub culture thing that we don't. If we have code snippets, we usually link out to actual GitHub UI in repositories.
The GitHub gists.
We don't use just all that much.
They are a handy thing for linking to code, especially if you want to be able to mark it up and have little conversations about the code.
We're usually doing it in the context of a PR anyway, a pull request. And those have got the same facilities, actually more. Y'all used the suggestion feature in pull requests yet?
So our commercial GitHub account is like an ancient one.
Oh, GitHub Enterprise?
I don't know what it is, but it's has none of the new fancy features. It's all like old school stuff.
Oh, you should tell your admin or convince your admin to upgrade.
Well, it's way cheaper the way it is now, so we're not upgrading.
I see.
Maybe eventually.
That's too bad.
Cool. I'm gonna head out, but thanks for the presentation. It was really good.
No problem. Thanks.
Take care.
I'm happy to chat a few more minutes. I've been looking at ECSs lately. Really like how Legion looks. And Shipyard was really interesting as well. It's like a little mini ECS. Really ergonomic.
I haven't looked at them in a while.
Yeah?
I tried. So I started writing a game long time ago when I first picked up Rust. I called it. Have you ever seen X-Pilot? Early, like.
Sounds familiar.
You play it on like Sun workstations.
I think I
like
did
an early
see that.
Unix X Windows game. It's like.
Did they have it on HPUX?
Yeah.
My college had HPUX.
Yep, a bunch of those early Unix workstations, you could run Xpilot, and it's like I forget the name of the arcade game, but it's like a vector graphics thing.
Like Asteroids.
Yeah, it's got that style, but it's also got like gravity and mass simulation. And there was like a capture the flag mode where you had to like hook a tractor beam onto a ball and get it over to some other location and drop it into a gate. Something like that.
Really? I think I glanced at it once, but I never actually played it.
Anyway, I was starting to do something like that. And I got it to the point where it'll like draw a grid and you can fly your ship around and you can shoot bullets. You can't hit anything, but there's nothing to hit. But the mechanics of flying around over the grid, those are all set up.
Cool.
And so I think I may have started integrating an ECS with that to handle stuff.
You think? It has been a while.
It's been like at least a year, maybe 2 since I touched it at all. But yeah, I started messing around with one of those and it seemed pretty cool, but I got sidetracked and so it's been sitting unfinished.
Yeah, back in the day, there was only specs that I could find that seemed
that's
decent at
probably
all.
the one that I was using.
But man, specs is like so. I don't know. It just seems like there's a lot of syntax to deal with. Legion is still. I think Legion is more powerful, and the syntax is better as well. And then Shipyard, wow, it's just like super ergonomic syntax, but it doesn't have as many features. But like if you just want like some basic ECS, it's like if I were doing something for like this project, for example, something like this level where I wanted to do it in an hour or two and show people and use an ECS, I would choose Shipyard. It looked really cool.
Yeah, that's
one of the few projects that actually has a user guide where they walk you through how to use it as well.
Yeah, that's nice. Let's see, maybe I like started with my Rust pilot source code and because yeah, I don't think it's in this. Yeah, this just uses Piston stuff.
Oh man, I tried that back in the day, but it always seemed broken every time I tried it. And then they said it was abandoned, so I didn't try it anymore.
Yeah,
I keep trying to use Amethyst, and it's just not working yet.
It's like a big, massive, incorporate everything kind of thing, which Piston was kind of too, except it really tried to keep everything separate. So you could pick out just small parts of it that you wanted to use. And this ended up being not super complicated. I really like how it worked out.
Cool.
Yeah, let me see if I can paste a link in the chat or something.
I'm teaching a day-long, well, assuming the virus ever goes away,
yeah.
In July, I'm scheduled to teach a day-long Rust crash course. And for that one, I'm taking some of my projects and making a little Rusty engine just to make it really easy to open an OpenGL context and draw something to the screen, and like, so that we can focus on the logic of moving a race car around on the screen and detecting whether it collides with something and making it explode and stuff like that.
Nice.
I don't
Sounds
think
like
it's
fun.
just don't think I have enough time. I'm trying to decide, should I like integrate Shipyard into it? I have a day, but I'm not sure I want to go over the concepts of an ECS when I'm trying to teach Rust.
Yeah, it's always tricky. So
Yeah.
there's
Rust pilot.
trying to put together the microcontroller stuff. There's just so many things that you could go over with, you know, how do microcontrollers in general work? How does this one specifically work? How do all the libraries that are involved work? And how do the more advanced libraries work? And what are all the APIs? And yeah, covering even a fraction of it would be difficult. So I've got something that's put together that's kind of at the same level as the Rusty Sword game, although it's got a lot more. It's simpler in what it does, in that it's just displaying some stuff and moving it on the screen, but it's doing it in a microcontroller. So
Wait, in a microcontroller?
yeah.
Then what's
So
the screen?
I've got one of them right here. It's kind of all. So you've got a little
Cool.
screen there.
I didn't realize. I missed. You said that before, and I missed it. I just
You've
cloned
got
your
a-
thing, and I was going to try to run it, but like without a microcontroller, I don't think it's going to work.
Oh, this is completely different. The Rust pilot thing is different. So
Okay.
yeah.
I'm going to try it out. Rust pilot. Cargo run. See if it works. Piston.
So assuming that my versions are okay, it should work.
Well, thanks everyone. I need to drop now. I'll see you next month.
We'll see you, Daryl.
All right. See you then.
I really want a Mac Pro.
Hmm.
It'll compile Rust. I mean, Rust will be so much snappier on a Mac Pro. My dream machine is a Mac Pro 16 core.
Yeah. I just want to get like one of those massive multi-core AMD chips.
Oh, hey, it worked. I've got a triangle and a grid. What do I do?
I think WASD and the spacebar probably, maybe the arrow keys. I don't remember for sure what the
Spacebar shoots. WSD is not working. Maybe arrows. Yep, arrows are working. Oh, look at that! I got near the edge of the screen and it started moving.
Yeah,
the grid.
it should stop you when you you actually hit a wall. So it's a really large space, but it'll scroll around
Yep.
until you get to
The
the
wall.
edge.
Any other functionality?
Nope, that's it.
It's working. It seems really smooth. The acceleration works well. It's taken my turns during acceleration. Oh, you have negative acceleration too. Fun. Positive and negative. The shooting seems to work. Let's see
Yeah,
if
you can, if you're really good, you can run into your own bullets.
Yes, I know. I just noticed that. Now that's interesting.
Yeah, so I got as far as getting the basic controls and movement down. And then I got kind of swamped in thinking about what to do about like multiplayer and network stuff. and
Oh my gosh, that is so hard.
you know, loading maps and things like that. So
Yeah, you definitely want to get the. That's where you do want to pull in things like ECSs, and you got to get that network model all figured out up front before you make your game. Otherwise, you're making like 3 games.
yeah,
The game without networking, the game with networking you think will work, and then if you're lucky, the game with networking that actually works.
yep.
I've never made it to that 3rd stage.
Yeah, so I'm pretty happy with how I got the code as is, but I'm not sure if I would end up doing it exactly the same next time.
Well, you never do.
Yeah.
You'll always do it different if you redo it.
Yeah, it did end up being relatively clean, I think. Maybe not structured the way you do it with an ECS, but
Well, nothing is unless you use an ECS. I guess you could sort of manually approximate an ECS, but if you were going to go to all that trouble, you might as well use an ECS, huh?
yeah, definitely.
I still got on my list to actually learn macros. I've gone this long and I still haven't learned how to write my own macro.
Yeah, I've used just a couple of them, but they can wipe out a ton of boilerplate.
Yeah, I just haven't gotten myself in a position where, oh, I'm writing a bunch of boilerplate.
So I was doing a parser for like an OpenBSM thing, if you know what OpenBSM is. It's a security thing built into BSD family operating systems that it basically audits all the low-level system calls. It allows you to say, okay, give me a log of everything that happens with these particular system calls, and then you listen on a kernel pipe, and it just shoves a bunch of binary data at you in this like a descriptor-based format. And so you have to parse all the binary descriptors that all have their own formats and everything. So it's basically a parser. But I wrote it with sort of a visitor pattern style, and that requires certain amounts of boilerplate to set up all the visitor stuff. And yeah, I just did all the boilerplate with macros.
Nice.
And it cleaned things up quite a bit. And macros are actually used pretty heavily in the embedded Rust community right now, because they have some really interesting strategies around zero cost abstractions that are still safe. So you get, you know, several layers of like zero size types with phantom type parameters and whatnot, so that you can say that this API requires like 3 pins that are in specific states. So you have to configure the pin to get it in the right state, and then you pass the 3 of them into the thing. And you just end up with a pointer that is like generated by a static function. So it compiles to like really efficient code. But there's like tons and tons and tons of actual source code involved in because you've got all of the different options spelled out and chosen at compile time based on what state things are in. So there's like every single thing has its own type, and like types that are specific to states as well. So like every state has its own type, and every pin has its own type. So the pin type is parameterized by the state type. And anyway, you get a bunch of code, and a lot of it's generated by macros. So you don't have to repeat for each pin because they have their own types.
That's cool.
The generic system is not quite powerful enough to just write the code once, even though it's identical code. the compiler ends up getting rid of it in the end anyway. But in the meantime, there has to be a lot of source code for it to go through. Anyway, it's cool stuff. It's better than not having macros, having other features to take care of that stuff would probably be better still. But, you know, trade-offs.
Yep, always trade-offs. Oh, cool. I noticed you got a CRT back there.
Oh, yeah, I've got tons of weird old stuff. Like, I've got a Mac
Oh, you're not
Plus.
kidding. Holy cow.
That was my childhood computer.
Oh, I loved that in the computer lab in school. I loved how you put the floppy disk and it sort of sunk back in. I was like, there's no way to get it out. This is so crazy. And then you dragged it to the trash and it came back out and it was like magic.
Yep. Yeah. So this actual computer was my computer as a kid. My dad held on to it for whatever reason.
Wow.
It actually got used for a remarkably long time. Just because he had bought a laser printer with it, and laser printers never die.
No, they don't.
These things never die. And so it was, I mean, in the early days of like PC word processing and stuff, it was terrible. So whenever my dad needed to write up a paper or something, or, you know, the software on there was, you know, like simple and it just worked and he knew how to use it. So it received a lot of use for like 10 years or something.
Wow. That's awesome.
And then
I like durable stuff.
Yeah. He wasn't really sure what to do with it after that. And it fit in its own little carry case that was padded. And so it just kind of sat in closets and stuff for years and years. And during the last move, I said, hey, I'll take that off your hands. All I had to do was replace a RAM stick.
Oh, interesting.
One of the 4 1 gig or 1 meg SIMs had gone bad at some point.
Bet it was a capacitor. It's always a capacitor.
No, it was just, you know, RAM is one of those things. Early CMOS technology didn't have as much protection from static electricity and stuff.
Oh,
so
that's true.
Like early RAM chips tend to go bad as it just static electricity over time just kind of like the CMOS, the metal oxide semiconductor technology. There's like a super thin barrier that's the metal oxide separating the
transistor.
Yeah,
the source from the drain.
Yep. Because it's a field effect. You can't have actual current flow. It has to be blocked off.
Right.
But that layer that blocks it off, that acts as the source of holding the charge that generates the field that does the field effect. That's very sensitive. The voltage gets too high and electrons start punching holes through the barrier to get through. And the more little holes that get broken through, the more leakage current you get. And eventually it wears out and is just bad. So that's, these days, it's a lot cheaper, I guess, to build in protection diodes to all of the inputs and outputs on CMOS chips. So
interesting.
This is why you can get away with not doing the static straps and all that. But
yeah, I've noticed it's been a long time since I zapped something.
They were super important back in the day because you had unprotected CMOS inputs on a lot of chips. And yeah, apparently RAM chips in particular would be vulnerable and would go bad. And I guess early RAM chips, like that was Intel's first product line was RAM chips. And there were just tons of bad ones just out of the fab.
Interesting.
Things have got better.
Much better for Intel. So
Yeah.
AG, are you here?
I think he's probably wandered off.
Yeah, I think he's unattended. Well, I've got to head out. I was just going to say bye.
Oh yeah. Well, thanks again. That was really
Yeah.
cool.
No problem. And thanks for your comments. I learned a couple things.
Oh, no problem. If you end up doing anything with Rust Pilot, let me know. You're
Sure.
welcome to fiddle with it all you want.
I don't think I'll get to it. I've got a big
Yeah.
course to make. But yeah, absolutely. If I
Can't-
ever do fiddle
Can't
with it, I will
blame you
let
for
you know.
that. Okay, see ya.
Okay, we'll see you.